All right, so we're back, and I think it's time to,
So very ready.
yeah, to wrap up our look at adaptive immunity. We've really been digging deep into how these incredible receptors work, but now I want to see them in action. I'm talking about how we use this system for therapies and vaccines, from the classics to the absolute cutting edge. So get ready for a rundown on different vaccine types.
Yeah.
We're going to talk about those mysterious adjuvants, and of course, the magic of memory cells. We'll even take a peek into the future with sorority therapy and personalized vaccines. Really fascinating stuff. So let's dive in.
I think what's fascinating here is that we're really moving beyond textbooks, and we're actually seeing these really intricate mechanisms being used in the real world to fight diseases and ultimately improve human health.
Yeah, it really is remarkable. It's like we've learned the language of the immune system, and now we're starting to write poetry with it. But before we get too poetic, maybe we should ground ourselves with a quick recap. How do these B and T cell receptors actually recognize the bad guys?
So imagine your immune system as this vast library, and it's filled with all these books, right? And each book represents a different B or T cell receptor. Each receptor is incredibly specific. It's like a lock waiting for its key. And the keys are antigens, these unique molecular patterns that you find on pathogens. So when a pathogen enters your body, its antigens, they search for the matching receptor. And it's this precise lock and key system that makes targeted therapies and vaccines even possible.
So it's not just about having a strong immune system. It's about having the right tools for the job. You wouldn't use a hammer to fix a leaky faucet, right?
Precisely. That's why we have this incredible diversity of receptors, each one equipped to handle a specific threat. And that brings us to vaccines. They're essentially training manuals for your immune system, introducing it to the enemy without the risk of a full-blown attack.
Okay, so let's talk vaccine strategy. It seems like there are a ton of different types out there. So what's the difference between, say, a live attenuated vaccine and an mRNA vaccine? And, who are they targeting?
So think of live attenuated vaccines as sending your immune system to boot camp. They use a weakened version of the virus, allowing your body to mount a full-fledged response and build robust immunity, like the measles or the chickenpox vaccine. But for folks with weaker immune systems, a boot camp approach might be too intense. That's where inactivated vaccines come in. They use a killed version of the virus, safer but sometimes needing booster shots to keep those defenses sharp, like the flu or polio.
So it's all about finding the right level of training intensity for this situation. What about those subunit vaccines?
Subunit vaccines are more like target practice. They use only specific pieces of a pathogen, like a protein or a sugar, to train your immune system on key targets. It's a highly targeted approach, often with fewer side effects, but can be a little trickier to develop, like the hepatitis B or pertussis vaccine.
So we've got boot camps, we've got target practice, and now mRNA vaccines. These are like sending a coded message to your cells, right?
Exactly. Instead of injecting the antigen directly, mRNA vaccines deliver instructions for your own cells to produce it. It's like sending a blueprint for building a defense system. Really cutting-edge stuff and super effective, like the COVID-19 vaccines.
Wow, it's amazing how much variety there is in the world of vaccines. And it seems like each type has its own strengths and weaknesses. So how do scientists decide which one is best for a particular situation?
It's a complex decision-making process for sure, taking into account factors like the specific pathogen, the target population, and even logistical concerns like storage and distribution. For example, mRNA vaccines offer rapid development and high efficacy, but they require ultra-cold storage, which can be a challenge in some settings. It's like choosing the right tool from a toolbox. You wouldn't use a screwdriver to hammer in a nail.
Right, it's all about matching the tool to the task.
Yeah.
But there's another tool we haven't talked about yet. Those adjuvants everyone's been buzzing about. What are they and why are they added to some vaccines?
Think of adjuvants as the personal trainers of the vaccine world. They enhance the immune response, making vaccines work better. Some adjuvants, like aluminum salts, create depots that slowly release the antigen. It's like a time-release mechanism, maximizing exposure and giving your immune system more time to learn and build up its defenses. Others, like certain molecules found in bacteria, directly activate specific immune cells, amplifying the danger signal and prompting a more robust response.
So they're not just passive ingredients, they're actively shaping the immune response. It's fascinating how we can fine-tune these vaccines for maximum effectiveness, but why aren't adjuvants used in all vaccines?
Well, it's a balancing act. While adjuvants can boost effectiveness, they can also sometimes lead to stronger side effects, like pain or swelling at the injection site. So scientists carefully weigh the benefits and risks for each vaccine and target population. It's about finding that sweet spot between maximizing protection and minimizing discomfort.
That makes sense. It's like anything else in medicine. You have to weigh the potential benefits against the potential risks. So we've got these vaccines triggering an immune response. But what happens next? How does our body remember these encounters and protect us from future infections? Enter the memory cell, right?
Exactly. Memory cells are the veterans of your immune system. They're created during that initial encounter with a pathogen or vaccine antigen. They hang out in your lymph nodes and spleen, essentially patrolling for that specific threat. If they encounter it again, even years later, they can mount a rapid and powerful attack, often preventing you from getting sick at all.
So it's like they've got a photographic memory for pathogens. But how long does this memory actually last?
That's the million-dollar question. It really varies depending on the pathogen and the vaccine. Some, like the measles vaccine, can provide lifelong immunity. Others, like tetanus, require booster shots to refresh those memory cells and keep them on high alert.
So it's like giving your immune system a software update. But what about those cases where our immune system isn't enough, like with cancer? That's where those revolutionary CRT cell therapies come in, right?
Cryo-RT therapy is a whole new level of immune manipulation. It's like taking your own T cells, the warriors of your immune system, and giving them a custom upgrade to target cancer cells directly. Imagine equipping them with special seek and destroy missiles that recognize specific proteins found on cancer cells.
That sounds straight out of a sci-fi movie.
Yeah.
But how does this actually work? Are we talking about rewriting their genetic code?
In a way, yes. We're genetically modifying these T cells to express a chimeric antigen receptor, or CRR, on their surface. This CRR acts like a guided missile, specifically designed to lock onto a target on cancer cells and trigger their destruction.
So we're taking these immune cells and giving them a custom-designed weapon to fight cancer. It's mind-blowing. But is this a cure-all for all types of cancer?
Not quite. It's showing incredible promise for certain blood cancers like leukemia and lymphoma, but we're still in the early stages of exploring its potential for other types of cancer. It's a rapidly evolving field with a lot of exciting research underway.
Well, it definitely sounds like a game changer for cancer treatment. And it makes you wonder what other diseases we might be able to target with this kind of personalized approach.
Yeah.
That's where these personalized vaccines come in, right? The idea of tailoring a vaccine to your unique genetic makeup is fascinating.
Personalized vaccines represent a paradigm shift in how we approach vaccination. Instead of a one-size-fits-all approach, imagine a world where vaccines are custom designed based on your individual genetic blueprint and immune profile.
So it's like getting a bespoke suit for your immune system. But how do we even go about creating a personalized vaccine? Where do we even start?
It all begins with understanding your unique immune fingerprint. Scientists can analyze your DNA to identify genetic variations. That might influence how your body responds to a vaccine. They can also assess your existing immunity to specific pathogens by looking for telltale signs in your blood.
It's like getting a detailed map of your immune system's strengths and weaknesses. And with that information, we can create a vaccine that's perfectly tuned to your needs.
Exactly. A personalized vaccine could be more effective and safer, minimizing the risk of side effects. It's like having a personal trainer for your immune system, tailoring a workout plan based on your individual goals and fitness level.
That's incredible. So what kinds of diseases could benefit most from this personalized approach?
The initial focus is on diseases where traditional vaccines have faced challenges, like cancer, HIV, and certain autoimmune diseases. Imagine a cancer vaccine that targets the specific mutations present in your tumor cells, or an HIV vaccine that evolves alongside the ever-changing virus, providing more durable protection.
Wow, the possibilities are truly endless. But are there any downsides to this personalized approach? It seems almost too good to be true.
There are definitely challenges. Developing and manufacturing personalized vaccines is complex and expensive. It's like creating a one-of-a-kind masterpiece. It requires specialized expertise and resources. We need to develop more efficient and cost-effective methods to make this approach accessible to everyone.
So scaling up production and making it affordable will be key. Are there any other hurdles we need to overcome?
Yeah, the regulatory landscape is another challenge. We need clear guidelines for approving and distributing personalized vaccines, ensuring safety and efficacy while navigating the complexities of individualized treatments. It's a new frontier, and we need to establish clear rules of the road.
It's like navigating uncharted territory. But the potential benefits are so enormous that I have no doubt we'll find a way to make it work.
Absolutely. The future of medicine is personalized, and vaccines are no exception. We're moving towards a world where treatments are tailored to our individual needs, maximizing effectiveness and minimizing risks. It's an exciting time to be witnessing these advancements.
It really is. It feels like we're on the cusp of a medical revolution, with the immune system as the driving force. Speaking of revolutions, I was reading about how scientists are discovering these microdomains within cells. They seem to play a crucial role in how cells orchestrate their responses.
You're absolutely right. These microdomains are like tiny compartments within cells, organizing specific signaling molecules and facilitating highly localized and efficient communication. It's like having specialized meeting rooms within a company, ensuring that the right people are in the right place at the right time to make decisions and take action.
So it's not just about having the right molecules, it's about having them in the right place at the right time.
Precisely. These microdomains are crucial for fine-tuning cellular responses. They're like miniature control centers, ensuring that signals are transmitted quickly and accurately to the appropriate targets. It's a level of organization that's truly mind-boggling.
It's incredible how much complexity is packed into a single cell. And these microdomains seem to be particularly important in the context of adaptive immunity, right?
Absolutely. Let's take T-cell activation as an example. When a T-cell receptor binds to its matching antigen, it triggers a cascade of signaling events that ultimately lead to T-cell activation. But these signaling events don't just happen randomly throughout the cell.
So there's a specific choreography to these interactions.
Precisely. Many of these signaling events occur within specialized microdomains. At the interface between the T-cell and the antigen-presenting cell, these microdomains act like tiny platforms, bringing together all the necessary molecules to ensure efficient signal transduction.
It's like setting up a stage for a crucial performance, making sure all the actors and props are in place for a flawless execution.
That's a great analogy. And these microdomains play a critical role in ensuring that T cells are activated only when they encounter their specific antigen, preventing unwanted immune responses.
This is like having a security checkpoint, making sure only the right signals get through.
Exactly. And this level of precision is essential for a healthy immune system. It's a delicate balance between responding effectively to threats while avoiding collateral damage to healthy tissues.
Wow, it's amazing how much is going on at the microscopic level to keep our bodies safe. It's a reminder that even the smallest details can have a profound impact on our health. We've covered a lot of ground today, from the intricate workings of B and T cell receptors to the revolutionary potential of personalized therapies.
It's been a whirlwind tour of adaptive immunity and its remarkable applications. And what's truly exciting is that we're only just scratching the surface. As our understanding of the immune system continues to grow, we can expect even more groundbreaking discoveries and innovations in the years to come.
It's a truly inspiring field. But before we get too carried away with the future, let's take a moment to appreciate the journey that brought us here.
It's a testament to the power of scientific curiosity and collaboration. From the early pioneers who first glimpsed the intricate workings of the immune system, to the modern-day researchers pushing the boundaries of what's possible with personalized therapies, it's been a collective effort spanning generations.
It's a story of perseverance, innovation, and a deep-seated desire to understand and harness the incredible power of the human body. And as we conclude this deep dive, I'm left with a profound sense of awe and wonder.
I share that sentiment. The immune system is a marvel of biological engineering, a complex and dynamic network that protects us from countless threats. And the more we learn about it, the more we realize how much more there is to discover.
It's a journey that's just beginning. But before we embark on the next leg of our adventure, I think it's time for a little break.
A well-deserved one, I'd say. We've covered a lot of ground today.
We have indeed. But don't worry, we'll be back soon to continue our exploration of the immune system.
And I, for one, can't wait to see what other wonders we uncover. Stay curious.
And to you, our faithful listener, thank you for joining us on this deep dive. We'll be back soon with more insights and discoveries from the world of adaptive immunity. Until then, stay curious and keep exploring.
You know, it's amazing to think that all of these advancements stem from understanding those tiny receptors we talked about earlier. It just shows the power of basic science and how it can really pave the way for revolutionary therapies.
It's a beautiful example of how even the smallest discoveries can have a ripple effect, leading to these breakthroughs that can change the world. But you know, all this talk about these customized immune responses makes me think about the role of thyroid hormone receptors. I was reading that they seem to have a surprising connection to immune function, which I never would have guessed.
That's right. Thyroid hormone receptors, or TRs for short, are traditionally known for regulating things like metabolism, growth, and development. But recent research is revealing that they also play a crucial role in modulating the immune response.
So it's yet another example of how interconnected our bodies are, with all these different systems constantly talking to each other. But how do these TRs actually influence the immune system? It seems like a pretty big leap from metabolism to fighting off infections.
Well, think of TRs as conductors of an orchestra. They're present on various immune cells, including B cells, T cells, and macrophages. And they act as transcription factors. Basically, they control which genes are turned on or off, influencing everything from inflammation to antibody production.
So they're like the DJs of the immune system, playing the right tunes to keep everything running smoothly. But what happens when these TRs aren't working properly?
That's when things can go awry. Too much or too little thyroid hormone can really throw the immune system off balance. For instance, in hypothyroidism, where thyroid hormone levels are low, the immune response can become sluggish, making people more susceptible to infections.
So it's like the music's playing too slow, and the immune cells just aren't moving to the beat.
That's a great way to put it. On the other hand, in hyperthyroidism, where thyroid hormone levels are too high, the immune system can go into overdrive, potentially leading to autoimmune disorders, where the body starts attacking its own tissues.
So it's a delicate balancing act, with thyroid hormone levels acting as the dimmer switch for the immune response. Too low and the lights are dim. Too high and they're blindingly bright.
Exactly. It highlights the intricate interplay between the endocrine system, which produces hormones, and the immune system. It's a reminder that our bodies are incredibly complex, and that maintaining balance is really key to good health.
It really is a symphony of systems working together. This deep dive has been a whirlwind tour of adaptive immunity and its applications. We've covered everything from the basics of B and T cell receptors to cutting-edge therapies like CRT cells and personalized vaccines.
And we've seen how understanding these fundamental mechanisms is opening doors to new and innovative treatments that are really transforming the landscape of medicine.
It's an exciting time to be following this field, with new discoveries and breakthroughs happening all the time.
Absolutely. The immune system is an incredibly complex and fascinating system, and we're only beginning to unravel its mysteries.
And speaking of mysteries, one thing that really caught my eye in the research was the mention of something called exhausted T cells. It sounds a bit dramatic, but what exactly does it mean for a T cell to become exhausted?
Exhausted T cells are a bit like marathon runners who have hit the wall. They've been fighting for so long that they've lost their stamina and effectiveness. This often happens in chronic infections and cancer, where T cells are constantly exposed to high levels of antigens.
So it's like they've been battling nonstop and their batteries are drained.
Precisely. Over time, these exhausted T cells lose their ability to proliferate, produce cytokines, and kill infected or cancerous cells. They essentially become dysfunctional, allowing the disease to persist.
Now, it sounds pretty discouraging. Is there any way to rejuvenate these exhausted T cells and get them back in fighting shape?
That's a major focus of research right now. Scientists are exploring various strategies to reverse T cell exhaustion, such as using checkpoint inhibitors to release the brakes on the immune system, or developing therapies that boost T cell metabolism and restore their energy levels.
So it's like giving those tired marathon runners a much-needed energy drink. And maybe some coaching to help them regain their stride.
That's a great analogy. Reversing T cell exhaustion has the potential to revolutionize the treatment of chronic infections and cancer, unleashing the full power of the immune system to eradicate these diseases.
It's amazing how much we're learning about how to fine-tune the immune response. We've gone from basic vaccines to genetically engineering immune cells, and now exploring ways to revitalize exhausted T cells. The possibilities seem endless.
They truly are. The field of immunology is advancing at an unprecedented pace, and we can expect even more groundbreaking discoveries and transformative therapies in the years to come.
Well, I'm definitely feeling inspired and hopeful after this deep dive. It's incredible to see how our understanding of adaptive immunity is leading to such innovative and life-changing treatments. But before we get ahead of ourselves, there's one more piece of the puzzle we need to explore.
And what's that?
Well, we've talked about how the immune system recognizes and fights off pathogens. But what about the aftermath? How does our body clean up the mess and repair the damage caused by an infection or injury?
Ah, yes. The resolution phase of the immune response is often overlooked, but it's just as important as the initial attack. It's all about restoring balance and returning to a state of homeostasis.
So it's like the cleanup crew coming in after a big party to tidy up and make sure everything's back in order?
Precisely. Once the threat has been neutralized, the immune system needs to shift gears from attack mode to repair mode. This involves a carefully orchestrated process of removing debris, dampening inflammation, and promoting tissue regeneration.
So it's like a well-rehearsed dance, with different cells and molecules coming in at the right time to perform their specific roles.
Exactly, and this resolution phase is crucial for preventing excessive inflammation and tissue damage, which can lead to chronic diseases and long-term health problems.
So it's not just about winning the battle, it's about winning the peace as well.
Exactly. A successful immune response involves both effective pathogen elimination and efficient resolution and repair. It's a delicate balance that ensures our long-term health and well-being.
It's a beautiful symphony of destruction and creation, attack and repair all working together to keep our bodies functioning optimally. It's a testament to the incredible power and complexity of the immune system.
I couldn't agree more. It's a system that never ceases to amaze me. And as we continue to delve deeper into its mysteries, we can only marvel at its intricate workings and the boundless potential it holds for improving human health.
Well, I think we've earned ourselves a little breather after that whirlwind tour of the resolution phase.
Agreed. It's always good to pause and reflect on the incredible journey we've taken.
And to you, dear listener, thank you for joining us on this deep dive into the fascinating world of adaptive immunity. We'll be back soon to wrap up our exploration and leave you with some final thoughts to ponder.
Until then, stay curious and keep exploring the wonders of science.
Okay, so we're back, ready to wrap up our epic journey through adaptive immunity. We've covered so much, from those remarkable B and T cell receptors to these cutting-edge therapies that are rewriting the rules of medicine.
It's been quite a ride for sure. We've explored how our immune system learns, adapts, remembers, and we've seen how scientists are harnessing this knowledge to develop some incredible new treatments for everything from infections to cancer.
Yeah, it's mind-boggling to think how far we've come, and even more exciting to imagine where we'll go next. But before we get too lost in the future, I wanted to circle back to something we touched on earlier, those microdomains within cells. They seem to play such a crucial role in how cells communicate and coordinate their responses.
You're right, those microdomains are like these bustling city centers within each cell. It's where signaling molecules meet, interact, and trigger specific actions. And they're essential for ensuring that signals are transmitted efficiently and accurately, preventing chaos and confusion.
So it's not just about having the right players, it's about having them in the right place at the right time.
Precisely. Imagine a factory where all the workers and machines are randomly scattered. Nothing would get done. Microdomains provide that organizational structure, ensuring that cellular processes run smoothly and efficiently.
That makes perfect sense. And these microdomains seem particularly important in the context of adaptive immunity, right? Especially when it comes to how T cells get activated.
Absolutely. Remember, T-cell activation is a highly regulated process. It's like a delicate dance between a T-cell and an antigen-presenting cell. The T-cell receptor needs to bind to its matching antigen, but that's not enough.
So there are other signals involved. It's not a one-step process.
Exactly. The T-cell needs additional confirmation, like a second opinion, to ensure that it's truly encountering a threat that needs to be addressed. This is where co-stimulatory molecules come in.
So it's like a double-check system to prevent false alarms.
Precisely. And guess where these co-stimulatory molecules often congregate? You guessed it, within specialized microdomains. At the interface between the T cell and the antigen-presenting cell, these microdomains create a highly concentrated signaling hub, ensuring that all the necessary signals are delivered in a timely and coordinated manner.
So it's like setting up a secure communication channel, making sure the message gets through loud and clear.
That's a great way to put it. And this level of precision is crucial for a healthy immune response. It prevents T cells from getting activated unnecessarily, which could lead to autoimmune reactions and other problems.
Wow. It's amazing how even the tiniest structures within our cells can have such a profound impact on our overall health. It really highlights the importance of understanding the immune system at all levels, from the molecular to the cellular to the systemic. This deep dive has taken us on an incredible journey. Through the intricate workings of adaptive immunity, we've explored its remarkable specificity, its ability to learn and remember, and its incredible potential for fighting disease.
It's been a privilege to share this journey with you. The immune system is a true marvel of nature, and we're only beginning to uncover its secrets.
It's a field that's constantly evolving, with new discoveries and innovations emerging all the time. And as we conclude this deep dive, I'm left with a profound sense of awe and wonder.
I share that sentiment. The immune system is a testament to the power and resilience of life itself. It's a force that protects us from countless threats, and its potential for improving human health is truly boundless.
So as we wrap up this episode, what's one final thought you'd like to leave our listener with? What's the key takeaway you hope they carry with them from this deep dive?
That's a great question. Here's something to ponder. We've seen how the immune system is incredibly complex and constantly evolving. It's a dynamic network of cells, molecules, and signals, all working together to keep us healthy. But this complexity also means that there's always more to learn. So stay curious, keep asking questions, and never underestimate the power of your own immune system.
That's a perfect note to end on. Stay curious, dear listener, and until next time, keep exploring the fascinating world around you and within you.